right, people. So today we are going to be covering the next section in the book. Well, it's still on 5.5, but we're going to see how the mole fraction kind of ties in with Dalton's law of partial pressures. Now, on the last video when we talked about Dalton's law of partial pressures, this was the equation. The P total was equal to the three different pressures. And since pressure can be written using the ideal gas law, if we have an ideal gas, then we saw that there's a relationship between this where R, T, and V are constant, right? The R is the same for all gases, the temperature was the same, the volume was the same. So the main relationship between this was the pressure and the number of particles. So the pressure of a gas is directly related to the number, or the number of moles involved. That's what the letter N is, the number of moles. So with this relationship, that pressure is related to moles, well, it gives rise to the idea that each gas contributes its own portion of pressure depending on how many particles there are of that gas. So each gas has a ratio and how it affects it. All right, so let's check out a practice problem from the book that kind of uses this mole fraction. Now, this mole fraction it uses a letter chi or chi. I have no idea, man. I'm not Greek. I think it's chi. I should know this, but I don't. But I won't beat myself up. But the relationship between these two is there. Now, let's take a look at this problem. Let's just read it. A partial pressure of oxygen was observed to be 156 torr. Now remember, torr is the same thing as mmHg, same thing. With a total atmospheric pressure of 743 torr. Calculate the mole fraction of O2 present. Alright, so let's make a little list, and I have this stuff written out because I know it kind of wastes some time. It's still ugly. I did it ahead of time. It's still ugly. Don't ask why. So the pressure of oxygen, the partial pressure of oxygen was 156 torr. And the total atmospheric pressure was 743 torr. So there's a lot more gases besides oxygen in this problem, or in this mixture, but we only know of one of them. And we don't know the mole fraction, so that's what we got to look for. So this is pretty simple. We got the pressure of our gas and then the total pressure. That's all we got to do. So X, and it's not 1, it's oxygen, so we're going to put X of O2 is equal to 156 torr over 743 torr. And I should have my calculator out. 156 divided by 743, it should be, let's check it out, 156 divided by 743, 0.210. It's 0.20995, but we're going to round that to this number, and this number has no units. Why does it have no units? Well, look at this torr and look at that torr, it's gone. So the ratio, the mole fraction is O2, and if you wanted to turn that into a percentage, you multiply by 100 and it will tell you that this mixture is 21% oxygen. Pretty neat, pretty darn neat. Now, that's one type of problem, and that problem you find on page 187. It is titled Dalton's Law 2, I believe. Now, let's check out another problem. Did I have it down here? I did not. Let's bring that over to the other side. So the next problem. The mole fractions of nitrogen in the air is... So let's write some stuff down. Mole fractions. That's this. But it's the mole fraction of nitrogen. So I'm going to write this off over here. The of N2 is equal to 0.7808. Calculate the partial pressure. So we're looking for the partial pressure of N2, And we don't know it. It's telling us to calculate it. So a little question mark. I don't know. I'm so confused. When the atmospheric pressure, so P, and then, well, in the atmosphere. Oh, okay. So the atmospheric pressure. So they want us to know the partial pressure of nitrogen in the atmosphere. So P total. I'm gonna put PT for short. That's gonna be 760 torr. All right, and well, we're not using moles. Let's use this one over here. Let's use our pressure. So right here, this is N2. Wait. We know the value. We're basically using this right here. So let's just put in our values in here. Whoa. What the heck? Ah, thank goodness. I was scared for a second. But we know that the mole fraction was that. We don't know the pressure of N2, but we do know that the total pressure was 760 torr. Multiply both sides by 760 because it's at the bottom, it's dividing, so we're doing the opposite. And whatever you do to one side, you must do to the other because it's the law. And your math teacher will hate you if you don't, all right? And so will I. I won't hate you, but your math teacher will. Math teachers are like that, but they can be like that. They have every right to be. All right, so 760 times. Teachers don't have a right to hate you. We don't, except for like 3 of you. If you say stuff, no. All right, whatever. So the pressure. This one does have units because this has no units, and this has a unit. So the units here are torr. Mr. Sanchez, this only had 2 sig figs. Shut up. No, I'm sorry. It's 590 torr. I didn't mean to sound so rude. I'm nice, believe it or not. I feel like no one who's nice has ever said that. All right, here we go. Boom, that's our pressure. And that's basically how you do these types of problems. Very, very simple. Now, if people can be jerks. Problems can be jerks, right? Because if you take a look at this is moles. So if they give you grams of a gas, and then, you can kind of see where it's going. They can complicate your life. If they give you VNRT, well, that's the same thing as P, right? So just keep that in mind that even though you have the formula, sometimes the questions might give you less information, but it's information that you can use to figure something out. Everything is interconnected, so don't forget that, because that's how some simpler concepts can be made difficult. But hopefully this helps clear some of these things up for homework, for just do all these problems till you get to the next section. All right, see you later. Hasta mañana, or till next video or whatever.